Let's do something fun. Okay, so I honestly don't know anything about this. I found online, and it's posted by the AP College Board, and this is AP Physics 1 Algebra-Based Free Response Questions 2017 test. You can print it out. I'll include the link down below. I printed it out. I haven't looked at it at all. Now, I figure I'm just going to work through the problems. I've not looked at any AP Physics stuff. I have no idea about AP Physics. I'm a college physics professor, so I should be able to do this, right? Let's just do it. I'm going to do one question at a time, just in case, someone wants to search that one particular question. And I'm going to explain it the best that I can. I might even use Python. I'm going to use whatever I want. I'm not going to do the exact same thing that they would do. Well, let's get started. Okay, so I haven't even looked at the question. I'm just going to turn this off. Not even looking at it. Not until I get it on the paper. So here we go. Oh, that's not even a question. Good. This is kind of messed up. I can turn the light down. How about that? Let's turn this down. Okay. And it's a little bleed. It's little. I need to work on my lighting. Let's turn it down some more. Okay. Maybe that's good. Okay, so this page is constants. Okay, that's not even a question. Let's just keep that to the side. Oh, they give you equations. Okay, I don't think I need that. Here we go. Questions. Can you even read that? Well, I'll give you the link to it below. Questions 1, 4, and 5 are short free response questions that require about 13 minutes each. That's strange. 7 points. Questions 2 and 3 are long free responsive questions that require 25 minutes each. And so they're 12 points. Okay, so here we have 3 circuits. Question 1. Suggested time 13 minutes. I love that. This should take you 13 minutes. If it only took you 3 minutes, you did it wrong. If it took you more, then you're not ready. I don't know. In 3 circuits shown above, the batteries are all identical and the light bulbs are all identical. In circuit 1, a single light bulb is connected to a battery. In circuits 2 and 3, 2 light bulbs are connected to the battery in different ways. So right away I see this is in series. Oops, it goes up like that. And this is in parallel. I mean, that's the only 2 ways to connect these. Okay. Rank the magnitudes of the potential difference across light bulbs A, B, C, and D, and E from largest to smallest. Okay, so the largest, so let's say this is, they don't say what this is. Let's say this is 1 volt. It's a 1 volt battery, and I'm going to redraw these. So here's number 1. I'm going to draw these as resistors. So this is 1 volt, and this is R. And then here's the other one. They're in series. R, R, 1. And then finally we have this one. R, R. So I know that the Kirchhoff's loop rule says that if I start at any particular location and go around the loop, then the sum of the voltages has to be 0. So delta V is 0 around a loop. I wonder if that was one of the problems that they gave you, one of the equations. Oh, here. No? Okay, that's fine. So if I go around here, I get 1 volt, and then, so this is going to be 1 volt, this one, 1 volt minus IR equals 0. And so the potential across that light bulb is 1 volt, right? Because it has to be. So this is 1. Now what about this one? If I go around here, I'm going to get 1 volt, and then I'm going to get minus IR minus IR. So equals 0. So this and that have to add up to 1 volt. So these are both going to be half of a volt, right? Because they have to add up back to the 1 volt potential. So these are not going to be as high of a potential as that one. Now what about this one? For the parallel, I'm going to go around here and I make a loop. So I get 1 volt minus IR equals 0. So that one's going to be 1 volt. And if I do another loop, that loop, I get the same equation. So that's also 1 volt. So this is A, B, C, D, E. So if I rank these, A is going to be greatest, and D and E. Those are all 1 volt. And then it's going to be greater than, if any bulb set, okay, let's say this. A equals D equals E, then it's going to be B equals C. Does that work? That's a good ranking. Okay. That was part A. And I explained how I made that loop rule. Okay, part B. This lighting's bothering me. The batteries all start with an identical amount of usable energy and all are connected to the light bulbs at the same time. In which circuit will the battery run out of usable energy first? Okay, so here we have power equals delta E over delta T. This is the definition of power. And for a circuit, power equals I times V. Delta V, really, for a particular circuit element. So I can just calculate the power for each bulb. The one that has the greatest power, they all start with the same energy. So if I want to find delta T, it's going to be the change in energy over the power. So the one with the greatest power is going to last the least amount of time. So the question is, which one it will run out of usable energy first with the one with the greatest power? Okay, let's go back up to here. So if I know power is I times V and the voltage across this resistor is I times R, this is going to be I squared R. Is that useful? No, it's not useful. Because I don't know I. V squared, okay, let's do it this way then. So power equals IV, and Ohm's law says that delta V equals IR. So if I solve this for I get I equals delta V over R. If I plug that in here, I get power is delta V squared over R. Okay, so this one's going to have a power of 1 volt over R. Fine. This one, this is going to have half the potential. Okay, so let's say this, let's call all these R's as 1. So for circuit A, I get P equals the change in potential 1 divided by 1 equals 1 watt. Okay, this is P1. For P2, I get, here I have the change in potential across this resistor is half of a volt. So it's going to be 1/2 squared over 1 plus the other resistor 1/2 squared over 1. So this is going to be equal to 1/4 plus 1/4 or 1/2. So this is a half of a watt. This one is going to be 1 times 1, so it's going to be 1 watt and 1 watt, so a total of 2 watts. So this one is going to use up its energy first, then this one, then that one. Okay, and you can think of it this way, right? These are going to have the same voltage as that, so they're going to be the same brightness as that, but there's 2 of them. So you have to run 2 light bulbs at the same brightness. It's not going to last as long. These are going to be running at lower voltage, and you would think, oh, maybe it's the same, but it's not, because at lower voltage it doesn't use as much power. So if you go back over here, which circuit will the battery run out of usable energy first? 3. they want to check there. In which circuit will run out of battery, usable energy last? 2. Check. Okay, and I think I did an explanation of that. Okay, so that's question 1 for the AP Physics exam. I think I might do another question. If I fix my lighting. Okay, I'll talk to you guys later.